So some familiar names, some new names that I've not met before, but on the whole, yeah, my role at Siemens, as well as being technology and innovation manager, I take a lead with regards to cybersecurity for the markets that we deliver into, and also I'm highly active within kind of discussions with peers and government, etc., around policy for cybersecurity within the industries that we play. So this presentation should be complementary to what David Greenwood was talking about earlier on about resilience, particularly where you're talking about digital innovation, which opens up the attack plane to cyber threats, and that's very relevant for a lot of industries today. But given that we're talking about energy systems, yeah, I'll crack on and give you a bit of an overview from an industry point of view of what this means for our customers and for the likes of grids, smart grids, etc., etc. So the goals of the presentation, I'm going to highlight the drivers for cybersecurity focus in energy, provide an overview of the challenges of implementing cybersecurity, and give a brief introduction to the threats and treatment of risks. And hopefully, at the end, we should have some time for questions and answers. Okay, so what are the drivers? So there's three major factors which are driving the need for the heightened focus on cybersecurity, and they're not unusual. Everybody should be familiar with this one. It's really digitalization and the proliferation of industry Internet of Things and Industry 4.0, but also taking tried and tested models around digitalization, particularly for SCADA, and how you move that into a cloud environment as well. But what it's driving essentially is increased connectivity between devices and different layers of the operating model across corporations. So it's what it's actually doing is, yeah, it's providing great efficiencies in how we deliver, but also it's opening up the plane for.
Sorry, Dan. I think you're on presenter view. We can only see the notes and all that.
Oh, right. Sorry. I'll just swap it over again. There we go. Okay. I look at this screen now. That's fine. Okay. Attack frequency and severity as well. So there's a lot of headlines which I'll go through in the next couple of slides in relation to the increased focus of or interest in cyber attack on what is critical national infrastructure, and also regulation. So the government is now getting interested in getting involved with how do we drive resilience across industry, but more focus on those critical national infrastructures or essential services which sustain our society. So if we take a view on the headlines, so the attacks on business and personal IT systems, the commonplace in the world today, and although they're considered a nuisance, they are a new constant in the modern world. But there is that increasing level of interest and certain cases of attacks on systems which support those essential services which I mentioned just previously. A successful attack on critical national infrastructure would grab the headlines, and it really impacts businesses and society as a whole. And the economic and environmental, plus the safety impacts from a successful attack on critical national infrastructure can be catastrophic. So when we talk about IT, attacks on IT infrastructure in comparison to the systems which sustain the critical national infrastructure, by a large scale, you do a lot more damage if you can successfully attack critical national infrastructure. And the evolution of the threats, these can be traced back to 2010. So 2010, Stuxnet hit the headlines, and that was reportedly the first attack on an industrial control system. There may have been previous, but at that point in time, a lot of this type of activity was kept undercover. But it's more open. It's definitely more in the public eye today. But this was particularly a watershed moment for industry and Siemens in particular, because it was our ICS technology which had been exploited in that attack. And in 2014, Havex, that was an attack on the ICS vendor community. And what they were attempting to do in that attack was compromise legitimate vendor sites and transplanting Trojanized versions of software and applications, which when they were downloaded by customers, the attackers then gained access to their networks. And that highlights the importance of how you need to not consider just the customer or the actual operator of the essential services, but also the supply chain which serves it as well. 2015, 2016, so this was definitely what David mentioned earlier. So this again was another watershed moment, but for the power industry. So Black Energy and Destroyer, these were highly complex exploits which could be categorized as advanced persistent threats. And what they actually did was enacted DDoS attacks on the Ukrainian power grid. And what they were able to do was actually lock out operators and destroy communication channels and equipment, and also erase traces of digital fingerprints from the hack. And to enact something like that, that requires a deep knowledge of the target industry and the equipment that's deployed in that environment as well. So, in comparison to what would have come before that, in terms of people trying to access IT networks, you get into this domain, you really do need to know what you're doing. So, it just highlights the backing that the hackers had in being able to do that. But essentially what that ended up doing was cutting off 225,000 customers from the Ukrainian power grid over a sustained attack of 2 days. And in 2020, I've highlighted there as well. So there was a ransomware attack on a US gas facility, and that resulted in the shutdown of a pipeline for 2 days. And that, in essence, was a spear phishing attack, which led to the attacker gaining access to the IT network. But due to having limited segregation of the IT and the operational network, the ransomware, it actually spread across to the process plant. And there's also some more recent attacks on major gas pipelines and water plants in the US, which have hit the headlines as well. But I'll touch on that is the Colonial pipeline attack in a later slide. In terms of regulations, the regulations which exist in the UK and in the EU, they're fundamentally based around the NIS directive, or the NIS regulations, the Network Information Systems. And that is focused on how you implement management systems to be able to manage the threats of attack from bad actors. So they were adopted in the European Parliament, and they became law in 2018 in the UK as well. And that put illegal obligations on all operators of essential services, so the likes of National Grid, your distribution network operators, your rail infrastructure, healthcare systems, etc., etc. So they're all being tasked with the same regulations to drive in good practice, best practice into what they do as a daily basis. And the UK National Cybersecurity Centre, they are the single point of contact for EU engagement around the NIS regulations, and what they aim to do is be the technical authority who supports industry with regards how you implement these measures. So if you look at the graphic on the left-hand side, that gives you an overall view of what the NIS regulations is focusing on. They have 4 objectives. One is about managing security risk. One is about protecting against a cyber attack. One is about detecting cybersecurity events, and one is about minimizing the impact of incidents. And then there are a number of principles which sit around the outside of that, and the NCSC give guidance with regards to the wrap around the outside, so the skin of the onion, if you like, as to how they can support industry in deploying that. So what are the challenges? So why are we talking about the challenges for applying security to critical national infrastructure? So security for the IT domain is very mature, it's well understood, and therefore is it not just a case of applying the same to the energy system. But before I go on to describing why it's not, I want to kind of give you a little bit of an explanation around 2 acronyms which I've already used, but yeah, I'll be using them more in the next few slides. So when we talk about ICS, this is the Industrial Control System, to give it its full name, and that's a collective term which is used to commonly describe variants of OT systems, which provide the backbone for safe operation of many essential services that we rely upon as a society. The ICS typically includes both hardware and software, and that's integrated into a system which controls the physical environment with high levels of automation and safety critical functionality as well. So from manufacturing plants to mobility infrastructure to energy systems, it's the ICS which we rely upon to drive the continued and smooth delivery of those essential services. OT, operational technology, that's comparable as a term to IT, but the focus of that technology is critical to core business operations, and it's the OT which essentially is the component parts of the ICS. And IT-OT convergence is what's synonymous with digitalization, and it's where those traditionally discrete domains, they start to come closer and overlap and integrate. Cybersecurity concepts. So they can be condensed into this simplistic view. So there's a framework which exists in the US called the Nist Framework, and that gives a life cycle view, which is a widely adopted concept for targeting improvements to your cybersecurity posture. So around the outside, you've got identify, protect, detect, respond, recover. And these are all levers which need to be addressed if we're to be successful in securing the energy system or the critical national infrastructure. So when we say identify, we need to understand the business context and what are the assets and resources that support those critical functions. Then we look at how do we protect them, how do we safeguard the energy supply, and then we look to enact mechanisms for detection as well. So how do we identify any cybersecurity related event? And then we get into the respond and recover mode as well. So if we are ever exploited, then how do we successfully respond and recover the system? And in the middle of the life cycle, we need to consider how this is applied to the three domains of people, processes, and technology. And quite often when we're talking about cybersecurity, particularly as an engineer, it's quite easy to get sucked into the world of thinking about the latest and greatest technologies that you can apply to help secure the system. But as you can tell by the size of the cogs, it's not just the technology. It's more important really to think about the process, about what we do on a daily basis, but also people. And people play a huge part, as we'll see on some of the other examples of exploits as we go through the presentation. And then when we're considering the protection goals of the cybersecurity implementation, we refer to the CIA triad. So CIA being C, confidentiality of data. We're focusing on reducing the risk of data loss. I is for integrity of data and the operational function. So we make sure that the data and how things operate, the configuration is not corrupted. And then we've got availability of the system or the data within that system to make sure that it's accessible and it's working as it should do. So when we compare the IT domain and the OT domain, so what we've got here is a highlight of the differences and priorities. So when we consider the CIA triangle, within IT security, it's confidentiality. That is king. In essence, it's certainly when we talk about data, that, you know, and securing that, it's the prime goal. So in our IT infrastructure, we typically have personal details, we have records of intellectual property, et cetera. But then that's followed up by integrity of the systems and the data, but also availability. But in the OT security domain, on the right-hand side, it's more important that we focus on availability and safety. So we need to make sure, particularly if we're talking about power grids or energy systems, that the supply of that energy is maintained and it's not limited by the security measures that you're putting in there, but ensuring that it's maintained and secure from any attack which is going to actually cripple that system. And what that can lead to as well is issues around safety, particularly when you're talking about the likes of power systems. And if you lose power, you know, the ramifications of losing power has a knock-on effect for society as a whole. And then it's integrity and it's confidentiality. So confidentiality of data from an industrial control system, you know, it wouldn't make sense to anybody, so it's not that important. But then when we look at the systems themselves, so IT systems, you know, your asset life cycle is typically 3 to 5 years. You know, we change iPhones, we change our mobile phones quite frequently, we change our laptops quite frequently. And that's driven by obviously components and the next and best greatest technology coming out, but also through software providers as well, who will force a migration of software onto your platform. And sometimes it's not compatible, so you're then forced to upgrade the hardware. Whereas if you talk about the OT domain, you know, you're looking at life cycles of 20 to 25 years. You invest heavily. It's a high cost asset that you're putting in there, and you don't want to have to change that out every 5 to 10 years. And also the software life cycle of that. You know, it's only as good as when spare parts are available. So, but options to add security software, so it's very high on the IT security domain. It's, you know, there's a lot of technology out there and software which focuses on IT, but in the OT domain it's very low. And also if we talk about heterogeneity, so very low, so mainly Windows 10. But from OT security domain, we've got a lot of different variants out on the system. So particularly, you know, you talk about Windows 95, that's, oh my God, I wouldn't like to think about having to manage a system as old as that. And the main protection concept, standards-based, case and risk-based on the OT side. So, you know, we don't just apply security, we need to take a risk-based approach. And when we talk about availability, you know, the availability of the IT system is, you know, the range of minutes is acceptable. You can live without your email for a good half an hour, but you cannot live without your power system. You know, so you are looking at issues around that availability, that you need to maintain a constant supply of of energy. Therefore, your system must be available at 99.9% of the time. When we talk about IT/OT convergence, so to help visualize what we mean, particularly where we talk about the IT domain and OT domain, we can use this model, which is the Purdue Model. So this was developed in the 1990s by academics at Purdue University, and originally it was taken as a model for enterprise architectures. So when we talk about the OT domain at the bottom end, levels 0 to 3, then level 0 is the physical process. Here it's shown as a manufacturing plant, but in grids it could be the substation assets, the switchgear, the transformers, etc., etc. And then you have level 1, which is the intelligent and programmable devices, which perform functional, safety critical operations. Level 2, you've got the site or plant control room, the SCADA, which is used to supervise and monitor and control the physical process and aggregate data for the higher levels. And then at level 3, you've got the historians and the engineering workstations, which are customized systems based on software, operating systems such as Windows. And what they're used to do is to perform batch management, record data, etc., etc. And the communication between the IT and OT domain is typically it's a dedicated backhaul network, and that feeds information up to what could be a main data center or a control room. And then you've got level 4 and 5, which is the typical view of the enterprise system and the IT network as we know today. And this would typically hold software on there such as Oracle, SAP, Microsoft, etc., etc. So a recent example of where there's been an attack on the IT system and how that had a knock-on effect for the OT system would be the US Colonial pipeline ransomware attack. And it was confirmed that there was a $4.4 million ransom that was paid. It was first reported that was an attack on the industrial control system. However, that was later denied, or not later confirmed, that the ransomware only impacted the IT system. And the pipeline was actually shut down as a precautionary measure. So again, when we see the headlines, and the worst case is always portrayed that, particularly where you lose a pipeline or a gas line, that, all of a sudden it becomes a major issue. It is the industrial control system that's been corrupted. But, in some cases like this one, it is the IT infrastructure that's been manipulated, and there's been precautionary measures put in place. So if you implement this model simplistically and consider how to achieve an air gap between the OT and IT domain, and I use the term air gap loosely here, as there's obviously a clear connectivity between both IT and OT domains. This can be supplemented if you introduce what is known as the demilitarized zone. So that's level 3.5. And it's the DMZ, which includes a lot of the security systems such as firewalls or proxies, which are used to separate or air gap the IT and OT domains. And that's where the IT and OT worlds converge, which increases the attack surface for the OT system. And many existing architectures either don't have that layer or have very limited capabilities to enact the DMZ. And when we think about OT systems, again, when I talk about the life cycle of 20 to 25 years, when they were first installed, they were built with no cybersecurity in mind, and they didn't support any cyber controls such as encryption, strong authentication, and logging. But when we talk about cybersecurity as well, as we go on to the next couple of slides, the overarching aim of any program, you've got to try and protect as many assets as possible. And when we use the Purdue model, it allows us to, once we build that out for our infrastructure that we're looking to protect, it allows us to clearly see what the connectivity is between those different levels and the different domains, and allows us to start to focus on what the appropriate measures are that we want to put in place. So what are the real world challenges that industry are facing? So lack of visibility, so gaining and maintaining continuous visibility of those assets. And, what we recommend for a lot of the people that we work with is, services around proactively identifying assets, and then that allows us to then identify vulnerability and risk. But certainly if you don't know what assets you've got, then it becomes increasingly difficult to actually start to put any security measures in place. And it's a real world example that, a lot of the technology that is out there, people know what the high level asset is, but they don't know exactly what state that asset's in from a patch level or certainly what it's connected to. So there is a real challenge within industry to actually put a focus on making a critical asset list to allow them to put a focus into applying cybersecurity. Also, from the IT/OT crossover slide that I had on previously, patching is not sustainable. So patching of a multi-vendor or a legacy system It's extremely difficult, disruptive, particularly when you talk about energy systems and maintaining the latency and making sure that you have availability of the system. A lot of the activities around patching need to be planned in advance. You need to take outages on specific legs of the energy system, etc., and it all pertains to being high cost, very difficult to do, and particularly where they do have a lot of legacy assets and a number of different assets. It's not like patching your Windows system. You need to really focus on what the impacts are for those specific vendor types of technology that you've got out there. Gap in cybersecurity capabilities advancements and ICS readiness to adopt the capabilities. So again, legacy ICS don't support security controls. And then we've got the lack of integrated IT, OT, cybersecurity governance. So IT investment has been king for a number of years. There's a lot of focus now on the OT environment, and is it suitably funded? Does it have the capability to roll out en masse? Questionable, but there is a big drive towards more investment in the OT domain. That's certainly where the likes of ourselves at Siemens are looking to support customers in achieving their goals in that area. Okay, so we've talked about the drivers and the challenges of applying security measures, but what are the threats and how do we manage the risk? So the threat actors and their motives, who's got an interest and what do we know about the threat actors? So this slide here gives a nice overview of the types of threat actors that we'd expect to see. You have your nation states, you've got your cyber criminals, you've got your hacktivists and terrorist groups, thrill seekers and insider threats. And the motivations for each is shown on the right-hand side there, is that for a nation state, it's typically geopolitical, looking to compromise the system or get access to IP or cripple a defense strategy of a government. Cyber criminals are certainly looking for profit and they're motivated by money, so they'll only attack if they can profit from it. Hacktivists have issues around kind of the environment and they've got some ideological motivations and some good examples of that as well, particularly listening to a podcast recently about a young hacker who took SeaWorld in the US to task and really done some damage to SeaWorld in terms of hacking their systems over a sustained period as well. Terrorist groups, so ideological violence, but then at the lower end you do have the just thrill seekers looking for the satisfaction of doing something, and insider threats of the organisation who just want to cause disruption because they're discontent that they're not getting paid enough. So, but when you look at the cyber threat actors on the left-hand side, the sophistication level of how they can actually resource and fund the type of activities that they're doing, as you move up that chain, there are a lot more resources available. Hence why critical national infrastructure is typically only the focus for the likes of nation states and cyber criminals and potentially hacktivists. But again, they need to be suitably funded. So the cyber kill chain, we have two stages. So when we talk about the threat vectors on the left-hand side, and one of those common threat vectors to the industrial control system, so it is that IT-OT convergence, where the IT system extends into the OT environment, and that can be leveraged by the use of social engineering as well, and some good examples of that in the media. Removable media, supply chain and physical security as well. People get access to a location, but again, flash drives are one of those, one of those items that everybody has, and do we suitably look after it and use it for the right purposes, or do we use it for cross purposes, i.e. personal and business reasons? I'll let you answer that question. But the cyber kill chain, so stage one, you're looking at how do you do some reconnaissance, how do you weaponize, and how do you deliver the payload into the infrastructure. Email has been the most common entry point, so phishing attacks, spear phishing attacks, and removable media is identified as the second most prolific threat to industrial networks, where we have a lot of activity of people accessing sites for commissioning and design work, and they've taken something in with them that they shouldn't have. And the second part of the cyber kill chain is looking to exploit, install the payload, command and control, and then deliver the malicious action on the back end of that. And that takes advantage of inherent vulnerabilities within the system around legacy and secure protocols, unpatched systems, flat networks, weak or no authentication, minimal to no logging or forensics. And patching is important, but it doesn't solve the problem of any inherent design problems. So when I mentioned earlier that we we look at a legacy of what's out there on the system, and security wasn't designed in at a point in time, then that is a big issue for a lot of the grid operators and other operators of essential services today. When we talk about compromises as well, so this graphic here gives you an indication of the time frames for delivering, or where there has been a compromise. It's took the majority, 87% of that, took minutes or less to enact. And then when you look after the compromise here, that how many are discovered quickly is only 3%, and then you have 2/3 that go undiscovered for months or more. So this is real statistics from a report, which I should have put the reference on there for. But if anybody's interested, I'm sure I can follow up and get that report for you. But what this highlights is that the lack of real-time visibility into the network, that leads to the inability to discover those early indicators of a compromise, hence why things go undiscovered for a long period of time. And this is indicative of what happened on in the 2015 cyber attack on the Ukrainian utilities, where the attackers were actually hiding themselves for 6 months without detection in the system before they actually exploited the attack. But if you consider adopting an appropriate model, which avoids flat architectures with appropriate segmentation, access controls, then that's fundamental to dealing with the challenge of people getting in there. But also what we classify as a defense in depth strategy as well. That is also key. And what that is looking to do is layer the walls of defense, both physically and logically. So cybersecurity is not just about internet connectivity, it is about the physical environment as well, and allowing people access to that. So risk treatment. So what we've got on here is a mapping of the relevant cybersecurity standards for power systems, and where we talk about guidelines for treatment of cyber risk, it's typically standards and frameworks that provide the North Star, if you like, for how we do this. And there's a number of them that exist today. But from a UK and EU, we know the Nist directive, or the regulations, they help support the addressing the practices and the policies for the organisation. But in other regions that are similar, such as the US, where there is the Nist cybersecurity framework. But specifically for the sector, there are domain-specific standards which can be considered alongside each other when addressing cybersecurity. So there are a number here, even though some of them are more prominent and more readily used. We do need to consider some of those niche standards which focus on maybe communication infrastructure, etc., etc. But one suite of standards which is considered foundational today is the IEC 62443. And what that does is focuses on the needs of the industrial automation control system, which, as I mentioned earlier, is the backbone of industrial processes and control systems. It's becoming referenced more and more, and it's fast becoming the prominent standard for addressing the introduction of an effective cybersecurity management system, or CSMS, for all stakeholders in the ICS supply chain, so owner-operators of infrastructure, system integrators, and also products and solution suppliers into that. And this is just a graphic to show the overview of how these standards play a part, and this isn't all the standards which play a part, but a sample of for the different parts of the supply chain. So Siemens, we're a product system supplier, we can also system integrate as well, so we need to be mindful of the standards on the right-hand side as well as others. But if you're an asset owner, the likes of National Grid or distribution network operator, then you're going to be focusing on certain standards and certain parts of standards, which are shown on the top there. And they're going to focus on secure operation, what are the policies that they need, and what are the requirements that they're going to put out to the market to say you must meet these requirements. For a system integrator, he's going to design and hand over or maintain a secure solution for the customer. And then from our point of view as a product and system supplier, we're going to engineer and deliver a secure system and product, but we'll also maintain the life cycle of that in a secure manner as well, and have all the mechanisms in place to inform both the system integrator and the asset owner of any issues, any vulnerabilities. And overall, a holistic risk-based approach needs to be taken. So again, I mentioned earlier around people, processes, and technology. So technology, yes, plays a big part in securing critical national infrastructure, and it's important that we maintain information-rich database and installed assets, review system architectures and OT system security capabilities, but also layer in new technologies as well, more best in breed, if you like, for, say, monitoring the likes of intrusion detection systems, firewalls, next-gen firewalls, deep packet inspection, et cetera, et cetera. These are the technologies which are becoming readily available today and need to be considered alongside the traditional technologies, which are more functional in nature and less security orientated. Processes, though, an organization, you need to plan and increase maturity of organizational responsibilities and the processes and work instructions as they apply to the industrial control system. But also we need to understand what are the gaps within the current environment. And what's becoming more and more evident is that from a government level as well, that cybersecurity, and I'm seeing it in the business today, is getting treated more and more like a health and safety culture. So where as a business ourselves, Siemens, we aim to have a zero harm culture, and our security posture is similar to that, is that we aim to not be exposed to any cyber risk and deliver products for our customers which won't which can be managed and suitably manage the risk of any exploits being enacted on them. But then you have people as well. So people, as a lot of the exploits and a lot of the threats and the headlines which have been out over the last couple of years, they typically start with a human element. So the spear phishing attack or the phishing attack via email, social engineering as well. So a lot of these attacks have started with the people element. So again, increasing security awareness across all business stakeholders and plan for acquiring the relevant security related skills and knowledge within the organization is a must. So in summary, digitalization, increased connectivity, regulation, and ultimately an active interest from threat actors are putting a spotlight on securing our critical national infrastructure. Challenges in securing CNI include legacy equipment with limited security capability, lack of security in design, lack of visibility of critical assets, operational constraints, IT focus and investment has been a priority to date, and cyber skills and domain expertise for implementing and managing cyber security for the OT environment. But also frameworks and standards provide the best practice guidance in tackling the implementation. Cybersecurity is a team game. That's a key point, and it needs to work across all stakeholders because we're only as strong as our weakest link, as I read it there. And cybersecurity is more than implementing technology. It needs a holistic approach, including people, processes, and technology. And that's it. Thank you very much. Any questions or that anybody has?
Thank you much, Dale. I think we've got time for a couple of quick questions if anyone wants to raise their hand. In the meantime, I just have one sort of question, which is where you were talking about the amount of time it takes to detect sort of a threat or somebody attempting to hack something. Could you use is the use of things like machine learning to try and detect this quicker, sort of automated sort of email scanning type thing to try and reduce the human element of that?
Yeah, certainly a lot of the technologies today are focusing on artificial intelligence. So certainly using machine learning, artificial intelligence. There's a lot of vendors that we work with who will, they're developing a system which will actually detect the assets on our behalf. So it's not somebody going around with a clipboard and a pen and trying to make a record of everything. You can apply technology which does that on your behalf and sniffs out all the different communication links between the different devices. And then from that, it actually develops a fingerprint of the communication between different assets. What does normal look like on a regular basis? You do get some events within just normal operations which need to be considered as well. So say if you had a high data flow through because of a fault on a physical network and you saw a lot of signals running around, again, you don't want the system to kind of either block. So you do have systems like intrusion detection, but you also have intrusion prevention systems, which detection systems are more passive, whereas a prevention system is obviously it's going to block any unusual behavior, and that's the worst case for some of these systems, these critical national infrastructure, because that's going to effectively cripple the system. But yeah, certainly the systems are out there. They provide the technology to connect. They provide a fingerprint for normal, and then they'll continue to monitor and flag up if there's anything that goes beyond normal.
Okay, are there any other questions